Welcome to the Timer Modules Course 1 of the HT8 MCU Basic Tutorial. This course will take you to understand the HT8 timer modules from the following 6 aspects, which are Timer Module Introduction, Timer Module Structure, Relevant Register Introduction, Programming Considerations, Compare Match Output Mode, and Timer Counter Mode. Timer Module Introduction. In MCU programming, the implementation of functions is often inseparable from timer modules. So what is a timer module? Its core is a counter that can be used for timing, measuring time, and controlling output. By inputting an MCU internal clock signal or an external pulse signal, each time a pulse is input, the counter will be incremented by 1. The counter will be cleared and restart counting until it reaches its maximum value or overflows. In this way, the MCU can know the counting time by reading the counter value. However, to implement complex timing operations, a single counter cannot meet the requirements. Therefore, the timer module core also includes 2 comparators, namely comparator A, which is responsible for comparing the counter value with the preset value of the CCRA register, and comparator P, which is responsible for comparing the counter value with the preset value of the CCRP register. They are used for timing different times. When the preset time is reached, the timer module can output the specified pin state and trigger the corresponding interrupt. In addition, the count pulse input of the timer module can come from inside or outside the system. Combined with the functions of input control, count and compare match and output control, the timer module can be used in timing, buzzer output, adjusting LED brightness, motor speed control, and other scenarios. What are the common timer module types for the HT8 MCUs? They are compact type, standard type, and periodic type. There are 4 common operating modes, namely compare match output mode, PWM output mode, timer counter mode, and single pulse output mode, which will be explained later in the course. It can be seen that the compact type timer module does not support single pulse output mode, and the standard and periodic type timer modules support 4 modes. In addition, the difference between the timer modules is also reflected in the bit width of the CCRA and CCRP. The counter and the CCRA register of the compact and standard type timer modules are 16-bit wide and the CCRP register is 8-bit wide. The CCRP is compared with the higher 8 bits in the counter while the CCRA is compared with all counter bits. Usually, the CCRP, CCRA and counter of the periodic type timer module are 10-bit wide. In this case, the CCRP and CCRA registers are compared with all counter bits. However, for some HT8 MCUs, the CCRP, CCRA, and counter of the periodic type timer module are 16-bit wide. As the CCRA and CCRP of the periodic type timer module are compared with all counter bits, the PWM duty cycle and period can be adjusted more finely. Users can choose according to their requirements. For more information, refer to the application note named HT8 MCU Timer Module Application Guideline. Next, we will take the standard type timer module as an example to explain. Timer module structure. The following is the HT66F3195 standard type timer module structure diagram. The whole can be divided into 3 parts. The first part is input control, which can select an internal or external clock source and can also select the external trigger pin function in the single pulse output mode. The second part is the timer module core. After the timer module is enabled and starts timing, the comparator compares the counter with the preset value of the corresponding register. The third part is output control. When a compare match occurs or the counter overflows, it can clear the counter, trigger the corresponding interrupt and output the specified waveform. As the timer module external pins are pin-shared with other functions, the relevant pin-shared function selection registers must be set in advance. Relevant register introduction. First, let's take a look at the STMC0 register, which is used to configure the clock source and operating status of the timer module. The STPAU bit is used to control the counter run and pause operations. When this bit changes from 0 to 1, the counter will pause counting and retain its residual value. When this bit changes from 1 to 0, the counter will resume counting from this value. The STCK2 to STCK0 bits are used to configure the counter clock source. The STON bit is the master switch of the timer module, with 1 indicating on and 0 indicating off. When this bit changes from 1 to 0, the counter will be stopped, but retain its residual value. When this bit changes from 0 to 1, the counter will be cleared and start counting. Next, let's look at the STMC1 register, which is used to configure the operating mode of the timer module. In the STMC1 register, we can control the operating mode of the timer module using the STM1 to STM0 bits. For example, when the STM1 to STM0 bits are set to 1-1, this indicates the timer module is in the timer counter mode. Note that when these bits are set to 0-1, this indicates the timer module state is undefined. Next, let's take a look at the STIO1 to STIO0 bits. When a compare match occurs, the STIO1 to STIO0 bit values determine the waveform on the STM external output pin. In different operating modes, the output function configuration is also different. In the compare match output mode, what states can the STM output pin select to output when a compare match occurs? At this point, the output pin can select no change, output high, output low, or toggle its present state. Then in the PWM output mode or single pulse output mode, what state can the STM output pin select to output when a compare match occurs? It can select PWM output in active state. When the output pin is active high, it will output a low level. It can also select PWM output active state. When the output pin is active high, it will output a high level. It can also select PWM output or single pulse output, in which case the waveform will be output according to the relevant configuration. As the external pin is not used in the timer counter mode, this bit is not used. It is necessary to only change the values of the STIO1 and STIO0 bits only after the STM has been switched off. Unpredictable PWM outputs will occur if the STIO1 and STIO0 bits are changed when the STM is running. Next, let's take a look at the STOC bit. It is used to configure the initial state of the external output pin when the counter starts counting, that is, when the STON bit changes from 0 to 1. In the compare match output mode, the initial level can be selected as high or low. In the PWM output mode or single pulse output mode, the control waveform can be selected to be active high or active low. This bit is invalid in the timer counter mode. The STPOL bit controls the polarity of the external output pin, with 0 indicating non-inverted output and 1 indicating inverted output. For example, if the initial level is high, it will output a high level when the non-inverted option is selected, and output a low level when the inverted option is selected. The STDPX bit determines which registers are used for PWM period and duty control in the PWM output mode. When the STDPX bit is 0, this indicates CCRP is used for period control and CCRA is used for duty control. When the STDPX bit is 1, the opposite is true. The STCCLR bit controls the counter clear condition. When the STCCLR bit is 0, the counter will be cleared when a comparator P match occurs. When the STCCLR bit is 1, the counter will be cleared when a comparator A match occurs. The STMDL and STMDH registers are the core of the counter, which are used to store the lower and higher 8-bit data of the counter value respectively and are readable only. The STMAL and STMAH registers are used to store the lower and higher 8-bit data of the CCRA preset value respectively. After the CCRA preset value is set, how to calculate the comparator A match period? Assume that the MCU uses the internal high-speed clock oscillator and the division ratio of the timer module clock is selected as 16, the unit counting period is 2 microseconds according to the formula. Assume that the CCRA preset value is hex 07D0, that is, the STMAL register is set to hex D0 and the STMAH register is set to hex 07. The comparator A match period is 4000 microseconds according to the formula. The STMRP register is used to store the CCRP preset value. How to calculate the comparator P match period? Assume that the MCU uses the internal high-speed RC oscillator with a frequency of 8 MHz and the division ratio of the timer module clock is selected as 16. The unit counting period is 2 microseconds according to the formula. When the CCRP preset value is 0, this indicates that the count value is 65,536. According to the formula, the comparator P match period is 131,072 microseconds. When the CCRP value is greater than 0, assuming the CCRP preset value is hex 08. According to the formula, the comparator P match period is S 4096 microseconds. Programming considerations. Reading and writing to this type of registers must be carried out in a specific way, otherwise it will result in unpredictable values. The counter registers are readable only and not writable. The CCRA and CCRP registers are both readable and writable. The high bytes of these registers can be directly accessed. The low bytes can only be accessed via an internal 8-bit buffer. Write the low bytes first, then the high bytes. Read the high bytes first, then the low bytes. Compare match output mode. Now let's introduce what is compare match output mode. After the counter is started, it is compared with the preset value of the corresponding register. When a compare match occurs, the output pin will output a specified waveform and an interrupt will be triggered. In the compare match output mode, when a comparator P match occurs, only an interrupt signal is generated. While when a comparator A match occurs, in addition to triggering an interrupt, the output pin will also output a specified waveform. External pin output, controlled by 3 units. The first is output control, which is responsible for configuring the initial level state of the pin and the associated output control. The second is polarity control, which is responsible for controlling the inverted output or non-inverted output of the configured pin. The third is pin control. The timer module external output pin is usually pin shared with other functions and must be configured as the timer module external pin in advance. This mode is suitable for occasions where general timing, buzzer output and other functions are required. What are the counter clear conditions in the compare match output mode? They are comparator P match clear and comparator A match clear conditions. The comparator P match clear condition is divided into 2 types. If the CCRP preset value is greater than 0, when the counter value is equal to the preset value, the counter will be automatically cleared to 0 and the STMPF interrupt request flag will be changed to 1. If the CCRP preset value is equal to 0, after the counter overflows, that is, the count value exceeds hex FFFF, the counter will be automatically cleared to 0 and the STMPF interrupt request flag will be changed to 1. The comparator A match clear condition is also divided into 2 types. If the CCRA preset value is greater than 0, when the counter value is equal to the preset value, the counter will be automatically cleared to 0. The STMAF interrupt request flag will be changed to 1 and the external pin state will be changed. If the CCRA preset value is equal to 0, the counter will be automatically cleared to 0 only after the counter overflows, that is, the count value exceeds hex FFFF. In this case, the STMAF interrupt request flag will not be changed to 1 and the external pin state will not be changed. Next, we use a timing diagram to help understand the operating process of comparator P-match clear. The x-axis is time, and the y-axis is counter value. The current CCRP preset value is 0, that is, the clear condition is a counter overflow. The STIO1 and STIO0 bits are set to 1-1, that is, when a comparator A match occurs, the external pin state will be toggled. After an STON rising edge occurs, the counter will be cleared and start timing, with an initial low level. When a comparator A match occurs, the STMAF interrupt request flag will be changed to 1 and the pin state will be toggled. Because the CCRP is equal to 0, the counter will not be cleared until it overflows, and then the STMPF interrupt request flag will be changed to 1, but the pin state will remain unchanged. When the CCRP preset value is greater than 0 and other conditions remain unchanged, the counter counts from 0 until a comparator A match occurs. The STMAF interrupt request flag will be changed to 1, the external pin state will be toggled and output low. The counting continues until a comparator P match occurs. The STMPF interrupt request flag will be changed to 1, and the counter will be cleared and restart counting. At this point, the STIO1 and STIO0 bits are set to 1-0, that is, when a comparator A match occurs, the external pin will output a high level. The counter counts from 0 until a comparator A match occurs. The STMAF interrupt request flag will be changed to 1, and the external pin will output a high level. The counting continues until a comparator P match occurs. The STMPF interrupt request flag will be changed to 1, and the counter will be cleared and restart counting. When the STPAU changes from 0 to 1, the counter will be paused and retain its residual value. After running, the counter will resume counting from this value. After a comparator A match occurs, the STMAF interrupt request flag will be changed to 1, however the output will not be changed because the current external pin state is high. The counting continues until a comparator P match occurs. The STMPF interrupt request flag will be changed to 1, and the counter will be cleared and restart counting. When the STON bit changes from 1 to 0, the counter will stop counting and retain its residual value, and the external pin will be disabled and can be controlled by other pin shared functions. After the STON changes from 0 to 1, the counter will be cleared to 0 and start counting, and the external pin state is initialized to a low level. Subsequently, when a comparator A match occurs, the STMAF interrupt request flag will be changed to 1 and the external pin will output a high level. Setting STPOL to 1 can invert the current level of the external output pin. The following is the operating process of comparator A match clear. The x-axis is time, and the y-axis is counter value. The current CCRA preset value is greater than 0, that is, the clear condition is a counter overflow. The STIO1 and STIO0 bits are set to 1-1, that is, when a comparator A match occurs, the external pin state will be toggled. After the STON bit changes from 0 to 1, the counter will be cleared and start timing, with an initial low level. It should be noted that when the CCRP register value is less than the CCRA register value, the comparator P match occurrence does not generate the STMPF interrupt request flag. When a comparator A match occurs, the STMAF interrupt request flag will be changed to 1, the pin state will be toggled and the counter will be cleared to 0. Set the STIO1 and STIO0 bits to 1-0, That is, the external pin will output a high level after a comparator A match occurs. The counter continues counting until a comparator A match occurs. The STMAF interrupt request flag will be changed to 1, and the external pin will output a high level. When the STPAU bit is changed to 1, the counter will pause counting and retain its residual value. After the bit is cleared to 0, the counter will continue counting. Because the current external pin level is high, the level does not change when a comparator A match occurs. When the CCRA is equal to 0, the counter will not be cleared until it overflows. When the STON bit changes from 1 to 0, the counter will be turned off and retain its residual value, during which time the external output pin can be controlled by other I/O pin shared functions. When the STON bit changes from 0 to 1, the external pin will be initialized to a low level, the counter will be cleared and start counting again. Setting STPOL to 1 can invert the current level of the external output pin. When the counter overflows, neither the comparator A match flag is generated nor the external pin level is affected. Timer counter mode. What is timer counter mode? After the comparator preset value is set, the counter is compared with the corresponding preset register respectively. When a compare match occurs, an interrupt will be triggered. The timer counter mode operates in an identical way to the compare match output mode, generating the same interrupt flags. The exception is that in the timer counter mode the STM output pin is not used. This mode is suitable for timing, counting, and other scenarios. Course summary. In this course, we have learned about timer module core composition, types, structure, relevant registers, programming considerations, and 2 operating modes. Through the study of this course, you will have a clearer understanding of the timer modules. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.